So today we're talking about ratio and proportion word problems. Ratio and proportion word problems. Let's talk about some ratios. I'll give you a really important ratio, girls to boys. You know what the ratio of girls to boys in this class is? What do you think it is?
If the number to another number.
I'll give there are 30 people total in the class. What's the ratio of boys to girls? What do you think it is? You think it's evenly split, 15 to 15?
10 boys and 15 girls.
I think we got 20 boys and 10 girls. Look at all the boys. They're all in the back. Yeah. All right? Okay. Boys to girls. I'm trying to make this real for you because we're going to be talking about this word ratio. Can you give me a ratio from your life that you might see? A ratio. Compare two things. Selena?
In a football game,
Okay, what are you going to compare?
Giants to the Mets, 10 to 5.
Sure. If you wanted to compare scores, Giants to Jets, you could say 10 to 5. I'll give you another example of things to compare. Let's compare, I don't know. What's up? Anyways, you get the point. Maybe we don't need to continue on with this. All right. Yeah, long hair, people with long hair to short hair. Okay? We've got boys to girls. How about how about teachers to students? Yeah?
How much rice?
Yeah. Cooking rice to water. Okay. Come on, let's go with this. Let's go with this. A hockey team, so these are word problems. One key strategy to solving word problems is writing down, taking notes. You learn that skill in history, in science, in English. It's useful in math also as well. So a hockey team played N games. So N equals number of games. Losing 4 of them and winning the rest. So 4 equals, is 4 equal to the games that they lost or the games that they won? Games lost, exactly. And if 4 is the number of games lost, how could we write an algebraic expression for the games that they won? There was n number of them, they lost 4 of them. Good, n minus 4, excellent. N minus 4 equals games won. Now, the ratio of games won to lost is, whoops, let me borrow this. Okay, now, let's talk. I'm going to give you some fancy notation. Won to lost. Do you see how I put those 2 dots in the middle? Those 2 dots basically mean 2. Won to lost. That's the same thing as me doing won to lost, which is also me the same thing as, what expression did I use for the number of games won? N minus 4. Excellent, Trevon. And what about games lost? 4. And there's our answer. Okay. During a recent, let's do number 2, right? We're going to keep talking. It's not going to get way too much harder than this, by the way. It's just getting used to comparing things. During a recent winter, the ratio of deer to foxes was 7 to 3. So let's write that down. That's useful. Deer to foxes. Deer to foxes was 7 to 3. You know what that means? That means that you can create a proportion that looks like this. Deer to foxes equals 7 to 3. Here's my question to you. Does this mean that there were 7 deer and 3 foxes? No, Julian, tell me, talk to me. What does it mean? You're the man. You are the man. There were 7 deer for every 3 foxes, so we could have had 70 deer. If we had 70 deer, how many foxes did we have? 30. It's a good thing. It's a good thing we didn't have any more of that, because you know foxes eat deer. Why is that disgusting?
It's their prey.
So what? People got to eat.
Like you eat chicken.
Yeah.
That's disgusting. So
Hey,
you eat chicken.
come on. Now, take a look. Take a look. Shh. Shh. Take a look. If there were 210 foxes, how many deer were there? What do you do? Have you seen something like that before? Cross multiply. We are cross multiplying it up. So that's 3x equals, what's 7 times 210? 1470, right? 1470. Let's divide both sides by 3. What do you get? What's 1470 divided by, what is it? That's it. That's the answer. So there's an area of science, reason you're in living environment this year, kind of just learning about the body, the world, about how science exists, right? You're going to eventually go into biology and chemistry is the blending of biology and math. And you're going to do stuff like this, like a molecule of water. A molecule of water, there are 2 hydrogen and 1 oxygen atom. Did you know that water is actually an equation? Water is H2O.
That's a show.
If you want to look at it in terms of if you want to look at it in terms of a picture, here's what a picture of water looks like. It looks like one of those oxygen atoms. It looks like one of those oxygen atoms with it looks like we're videotaping. We're recording. I'm telling you right now. So I don't know. If your parents have a big problem or you're causing trouble, I'm sending them this file. I'm going to tell them, go right here, just watch the video and see how many times we try and do a lesson, and the moment I turn around, you guys decide to have conversations. And it's only when I turn back and face you that you're quiet. Be like this when I turn around. Here's what a water molecule looks like. 1 oxygen and 2 hydrogens. So let's talk about this for a minute. What's the ratio of hydrogen to oxygen? Oh, nice. The ratio of hydrogen to oxygen is 2 to 1. Right? Let's talk about some other ratios that we could do. How about what's the ratio of hydrogen to each molecule of water? If you have 1 molecule of water, if you have one of these triangle-looking things, how many hydrogens come with one of those? 2. So hydrogen to water is also 2 to 1. Now, take a look at the question, right? How many atoms of hydrogen are in 28 molecules of water? How many? So, let's compare hydrogen. Whoops. You know what? I don't know if I'm going to have enough room to write out the whole thing. If you have hydrogen to water, normally that's a ratio of 2 to 1. But now we have 28 molecules of water. And how many hydrogens would go with that? Does anybody know? You guys are so smart. Let's cross multiply. X equals 56. You guys are so smart. Way to go. Wow. Maybe a lot of people, maybe you guys are ready for chemistry. Should we try it? Send you out to chem? So this is, you don't just buy gold. You can buy platinum, silver, copper, and all the metals that you can think of are worth money. Sterling silver that you see, sterling silver is called sterling silver because they mix it with copper, and that produces that brilliant shine to it. Otherwise, silver corrodes. You know what I mean? Gets all tarnished, gets all, dirty, oxidizes because of the air. So they mix it with copper in a ratio of 37 to 3. So in a normal silver bar like this, 37% of this bar is silver. And then the last, not 37%, I'm sorry, like 37, if it was, let's pretend that this bar has 40 grams to it. Oh no, that's mean. It doesn't. I'm getting held back. That's okay. We're gonna finish this one problem, then we're not gonna have any homework.
You don't have any homework?
Shh. Imagine that this bar has 40 grams to it. That's a big bar, by the way. 40 grams. If there's 40 grams, then 37 of the grams are silver and 3 of the grams are copper. They literally mix this in a gigantic molten pot where you have to be very careful. It's very dangerous. It's pretty cool. It's very dangerous. Okay. So here we go. So it's in a ratio of 37 to 3. Now imagine we're going to make a gigantic bar. 600 grams. 600 grams. Okay? 600 grams. Well, in a normal small bar, the ratio of silver to the total bar is 37 to 40. What would we have on this side? What's on the bottom? What's the total big bar? 600. That's a huge bar. I can't even imagine what that's worth. And what's on top? Because we're trying to figure out how much silver is in it. And then what do? Good. 40x equals, how much is that? I think it's 22,200, but I could be wrong.
Yeah, you're right. Very good.
Well, you got to be able to do that when you're negotiating with people for money. Okay? Divide that by 40, and I think it's like 20, that's like 5. I think it's like 550 grams. 5 grams. Yeah.